All right, so warm up today. We talk about GCFs here, and so I think, at least usually in Algebra 1, you guys do greatest common factors. And you talk about factoring out a greatest common factor. I think it fell, I guess this would have been 2 years ago. So never mind. I think you've seen this before. So if you have, you know what to do here. Go ahead and do it. If not, here you go. So GCF, greatest common factor, means you want to look at all the different terms. So like this one has 3 different terms. This one has 2 different terms. So you want to look at all the terms and say, is there anything that's common to all of these that I could factor out? And that's either, what's the largest number, or is there any variable that's common to all of them? So numbers wise, I think it's fairly obvious. These are all divisible by 5. So I can take a 5 out of everything. Now there's x's here and x here, but since there's no x here, we can't factor an x out of all this. So basically our GCF ends up being 5. And so what we do is we factor the 5 out. And so we say, if we divided a 5 out of all of these, what would be left? And so in this case, that would be 10 divided by 5 would leave you with 2, and then still the x squared. If you divide this by 5, you're just going to be left with the negative 1. So minus 1x, so you don't need to write the 1. And then 20 divided by 5 is going to be 4. And there we go. So that's what factoring out a GCF means, is you find the greatest common factor among all the terms, and then you factor it out and show what's left. Okay, so this one, just 2 terms. As far as the coefficients go, we can definitely factor a 3 out of those. And then actually in terms of the variables, they each have an n. So we can actually take a 3n out of each term. All right, so what does that leave us with? If we divide the 3 out of this, we're left with just 1. And if we divide one of the n's out, we're left with just n. So it's just going to be n. And in this case, 9 divided by 3 is going to be 3. And if we divide the n out, then there's no variable left, and it's just that. Now, if you're ever not sure on these, here's the thing, is once you think you've got it in this factored form like this, where you took your GCF out, if you want to check your answer, so this is your answer, but if you wanted to check it, you could go ahead and take this and distribute it and see, does it give me the same thing? If I distribute this, do I get this answer? So 3n times n is 3n squared, and 3n times 3 would be 9n. And so obviously you can see, yep, that's the same thing. So like I said, this is the factored form. This is what the problem asked you to do. But if you ever want to double check it, you can. Okay, so now I move down here. We have a 4, an 18, and a 7. So, like 4 and 18 are both divisible by 2, but 7's not. So in this case, there's actually no number besides 1, which 1 doesn't do anything for us, but there's no number that we can actually factor out of all our numbers here. There's also not an x here, so we cannot factor anything out of this. So the GCF in this case is 1, and what we refer to this as, you're going to see this today too, we basically just say this one is not factorable. There is no factors that you can take out of this. So you can say it can't be factored, not factorable, anything like that. All right, so now we move on. In this case, coefficient-wise, definitely a 5. And then variable-wise, there is a t in each of those. So we can take 5t out of both parts. So divide that by 5, you're left with 5. You divide this by t, you're still going to be left with a single t. All right. Now here, if you take 5t and you divide it by 5t, you're just going to be left with 1. Now in this case, it is a negative 1. And so there we go. That's going to be our answer. And we're looking good. So 3 of these factored, we were able to get GCFs, and one of them, there was no GCF, so we just left it as is. So we're going to use this skill today when we talk about factoring.